Today we are going to practice two different examples of logarithmic equations. Let's start with this one. To solve this equation, we have to take into account the definition of logarithm. Remember that if I have logarithm base A of b equals c, I can write this as a power. The base of the logarithm will be the base of the power. When we calculate logarithms, we calculate exponents. So this is the exponent that I need for this base. So that equals to the argument of the logarithm. You cannot forget about this. All right, so that's why I wrote it. So you keep this in your mind. Okay, so we are going to apply, since we only have one logarithm here, we are going to apply the formula. And that will help to solve this equation. The base of this logarithm doesn't appear here, and that means that the base equals 10. So in this case, this is the exponent that I need for base 10 to obtain this result. So I'm going to write it. 10 squared equals 2x minus 4 over 5. 10 squared equals 100, and this equals this. Now I need to isolate the x. So let's get rid, for example, of 5. It is dividing here, so if I multiply this side and this side by 5, this will disappear here. Or, as we always say, this is dividing here, it goes to the other side multiplying. So 5 times 100 equals 500, 2x minus 4. This is subtracting, it goes to the other side adding. It is like adding in both sides 4. So here we will have plus 4 and negative 4 plus 4 will disappear. So we would have this equals 2x. And to conclude, we just need to put this 2 in the other side dividing. Because here it is multiplying. And the final result will be 252. This is the final result. But we need to check the solution, because if I use this solution in the first equation and I have a negative logarithm, a negative number as the argument of the logarithm, that is not possible, because you know that because of the definition, logarithm of negative numbers doesn't exist. Logarithms don't exist. So let's place this number here. This would be 504 minus 4, that is 500, over 5, it is a positive number, that is 100, all right? So this solution is correct, and this is the answer. Good. Now we are going to solve this different logarithmic equation. Here we cannot apply this idea because we have many logarithms, and it is not possible to use this trick we used before. So we have to think about another different trick. That is, that if we have a logarithm base A, for example, of A, and we have a logarithm of the same base of B, if this is true, this logarithm equals this logarithm, since the logarithm and the base are the same, A must equal B. If not, it is not possible. So you have to keep this in your mind in this occasion. All right? So let's apply this. Let's apply this idea here. I would need to have just one logarithm here, base 10 in this case, because it is the base we're working with, and one logarithm here. So we have to apply the properties. Because of one property that we studied, and there's a video that talks about that, we can put these two logarithms together if we multiply the arguments inside the logarithm. So it would be like this. Here, I don't know what to do, but it would be useful to transform this number into a logarithm. So then using the properties, I could put them together the same way, but using the property that this would transform into an only logarithm with a division inside of the arguments. So let's write this as a logarithm first. And I need that 2 appears as a logarithm base 10 of something. So let's think about the definition again. Here I have 10, so it would be 10 using this exponent will equal what's inside the logarithm. So inside the logarithm, that is 100. I need to have 100. I'm sure you understood this perfectly. So now we can say that this equals logarithm of 100 minus logarithm of 25. Let's go on. Let's multiply this first. And we have to use, remember, distributive property. This times this, and then this times this, and this times this. 2x times 3x equals 6x squared. Then 2x times minus 2 equals negative 4x. Minus 3 times this equals minus 9x. And then positive 6. Here, as I told you before, using the property we have studied, we can write this as a division inside the logarithm. So now we have exactly what we were looking for. We have logarithm of something equals logarithm of another thing. So what's inside the logarithms must be exactly the same. So let's write it. Minus. And I got rid of logarithms. 100 divided by 25 equals 4. And now I just have a second degree equation. Let's rearrange this equation so we can use the second degree formula to solve it. So this will be 6x squared minus 13x plus 2, because this goes to the other side subtracting. Alright, so x equals negative b, that is 13, plus or minus a square root of 13 squared, which is 169, minus 4ac, that will be 48, all over 2a, that is 12. X equals 13 plus or minus, if we perform this operation, it will be square root of 121, and you know that the result is 11. If not, just use your calculator. And here we will have two possible solutions. This plus this, which is the result 13 plus this would be it would be 24. 24 divided by 12 will be 2. And 13 minus 11 will be 2 over 12. That will be, if we simplify, 1 over 6. Now don't forget that we have to check if these solutions make my arguments in the first equation we had negative, because if these results make any of the logarithms negative, that is not valid, and it is not a valid solution, because I can never have a negative number inside the logarithm. So let's work with 2. It would be 2 times 2, 4 minus 3, that equals 1. No problem, this is a positive number. And in this case, 6 minus 2, that is 4, no problem. So this solution is correct. Now let's try with 1 over 6. 2 times 1 over 6 would be 1/3. 1/3 minus 3 is a negative number, so this solution is not valid. So this is the only possible solution. I hope you understood. Bye, see you soon.